Okay, good afternoon, everyone. I'm going to be presenting a paper titled "The Data Mining Based Framework for the Identification of Daily Electricity Usage Patterns and Anomaly Detection in Building Electricity Consumption Data." So, this paper proposes a data mining based framework to extract, helpless, and discover insightful information hidden inside these patterns. This TELP stands for typical electricity load patterns, and these are patterns, or we could say similar activities, that are found inside temporal data of measured electricity data usage. And this paper combines supervised and unsupervised learning techniques, and the combination of these two techniques enables the authors to come up with an interpretable framework for knowledge discovery, and which makes it applicable for practical application like anomaly detection. And also proposed a new clustering method with two-step clustering analysis, and like the other one-step clustering methods. And we can see the performance of this proposed clustering framework compared to the other one-step clustering mechanisms. This is the general overview of the proposed framework. Here we have the here we have the oh, sorry here we have a raw time series data. This is a measured electricity usage over a specific period of time. This is a 1 year long electricity usage. And basically, this framework contains have three major phases, where the first phase is data preparation. Inside here, we have three steps. The first one is data pre-processing. This is where they dealt with outlier detection and dealing with missing values. And the second step is data segmentation. This is where they converted this 1 year long raw time series data into daily electricity usage patterns, or we could say DELPs. So instead of having electricity usage for over a year, we have now a daily electricity usage. So it's called DELPs. Data normalization, as they normalize the data on the third step. The second phase is identification of DELPs. Here as well, we have three steps, and the first one is feature definition. This is so normally a time series data have a higher dimension, as they do have many they're higher dimensional data, and clustering algorithms do not perform well in the in higher dimension, so we need to come up with a lower dimension representation. So what they did is they defined 5 statistical features, and they used this to train the clustering algorithm, and we're going to see how they selected these 5 features. And the second step is the removal of outliers inside the DELPs. So we have now a daily electricity load pattern, so we could say, load profiles, not patterns. And to remove the outliers, they used a DB scan clustering mechanism. And the third step is the identification of DELPs. So these are patterns, or we could say electricity usage activities, like similar activity of electricity usage. And to identify those, they used k-means clustering. And the third and most important part is phase is the knowledge discovery part. This is knowledge discovery, is basically means the to identify the relationship between the features in the identified clusters. So for this one, they used a CARS algorithm, or a decision algorithm. So this is means that identifying which are the most influencing features for the identification of the clusters. And finally, they discussed how how this framework can be used in to detect anomalous electricity load profiles, or anomalous electricity usage in a building. The case study has been done on 3 non-residential buildings that are located inside Chongqing, China, and this is the data electricity usage data from August 1st, 2012 to August 20th of 2013 of 3 buildings were collected. And in addition of the electricity usage, the building floor area, number of floors, construction years, heating or cooling system types, and also external data like weather data during that period were also collected. And these are the amount of data that they collected before and after they removing the outliers for the street building. So like I told you earlier, they defined 5 statistical features inside this daily electricity load profile. So how they did is, this daily electricity load profile is the electricity usage over 24 hours. So what they did is they divide this 24 hour into 4 segments. One is from midnight to 5 o'clock in the morning, from 5 to 10, from 10 to around 18, from 18 to the rest of the day, and they took mean of each segment. So now we have 4 features in here, and they added one feature to capture the shape of the graph. That is just, they took the difference between the peak load and the valley load. So that's the 5th feature. So in total we have 5 features. And to identify the outliers, they used DB-scan clustering algorithm. This is the 2D projection of this our daily electricity load profiles, and from this we can see that 2 clusters have been identified for all 3 buildings, and this convex hull represent the identified clusters, and this red crosses were the outliers. And from this we can see that even if this outliers lies inside the convex hull, they were perfectly or correctly identified as an outlier. And here from this we can see that DB-scan, we can conclude that DB-scan clustering did not identify all possible clusters, because 2 is not enough, because 2 might only represent the working hour and non-working hour of the building. So we need to do better clustering or further clustering analysis. And for that they used the k-means clustering, and they used done index to identify the optimal number of clusters. And here we can see that, so higher than index means a better clustering. So for the first building, from this we can see that 5 was identified as the optimal number of cluster, and then for the third building, 4 is the optimal number of cluster. And these are the clusters identified by the k-means. 5 clusters identified for the first building, and 4 clusters for the rest of the building. And if we take a look at this building A155, it has four clusters, and cluster 3 and cluster 2 have somehow similar activities, having a peak load from around 9 to around 16, say, or 17, around that. And same for the cluster 2. And cluster 1 and cluster 2 also have some similar patterns, except cluster 1 have 2 peak usages around 16, and it could be around 17 or 18. So it has 2 peaks. But cluster 4 has somehow low and constant electricity usage, indicating that this pattern might represent the when the buildings are not are unoccupied, or they were not in use. Yeah, here the knowledge discovery part, like I told you, this knowledge discovery is about finding the relation between the potential influencing factor or features and the identified clusters. For that, they trained a decision tree algorithm, CART, and this is the result from that. And we can see that this is the representation of the decision rules, we could say. And here we can see that holiday and temperature are the most influential features. And for that, they only tested was they identified 6 features, and they trained the decision tree on that. And from that one, we can see that holiday and temperatures are the most influential factors. And to compare the performance of the framework, they trained k-means and Gaussian mixture model to compare the performance of the proposed framework with the regular one-step clustering analysis. And these are the clusters identified by the k-means. 2 clusters were identified for all 3 buildings, and like I said, 2 clusters are not enough. So we can see that one-step k-means clustering are not good enough to identify clusters in electricity consumption data analysis. And also, this is the result from the Gaussian mixture model. Here, 2 clusters were identified for building first building, and 6 clusters were identified for for building 2 and 3. And here you can see that most of the clusters have somehow similar patterns. Here, this, even this, and like all of them are similar pattern. Here as well, you can see that they do have similar patterns, and this indicates that this model also didn't perform well. And as a conclusion, the generalizability of the framework could further be studied with larger data set, because they only studied on 3 buildings. So they might, to better analysis or to better see the efficiency of this framework, they might need to do more, like include more buildings and collect more data to to better come up with the generalizability of the framework. And also they might add more influential factors like the occupancy of the building, or include the non-working hour or the overtime working hour of the buildings. And other than that, they proved the efficiency of the algorithm and the framework, and it shows a better performance compared to the one-step clustering analysis. Yeah, thank you.